Hi, good morning. This is Trina here to discuss about quantum numbers. And this is the part of atomic structure. So we are at the third lecture of atomic structure. And if you have any doubt, so you can communicate with me either through my contact number or my email ID. So all this I have given in my personal information. And the most important part, that is the course page given here. So I have uploaded entire study materials and probable questions, semester questions, and the solved problems. So I hope that already you have registered with this code. So when you have done this, whenever it is done, then you can access the entire study material. So for the subject chemistry, the subject code is CH101 for odd semester, CH201 for even semester. So this course is for undergraduate BTech students, and the streams are CSE RT Civil Mechanical for even semester, Electrical EC and BME for odd semester. The credits are 3, contact hours 35, and weekly I will take 3 lectures. And the prerequisite knowledge required 12 standard to understand the concept of chemistry. So in chemistry subject, you will get the several concepts in chemistry. And in the outcome, the students will be able to describe the fundamental properties of atoms and molecules, atomic structure. They will learn about the atomic structure, the quantum numbers, the properties of atoms and molecules. So the entire lecture plan is given here, so you can understand that which topics will be covered in which day, so that you can take the prior preparation with the topic. So first, module 1, that is the atomic structure. So already I have covered the 2 lectures. Number 1, Rutherford model, its drawbacks, Bohr's models and drawbacks. So you have seen how Rutherford did the experiment with the gold plate, with the alpha particle, the bombard of alpha particle, and how the beam of the radiation deflected. And from this deflection, he drawn the conclusion, and we got the postulates, several postulates from the observation, from his observation and the conclusion. But it was not flawless because it was unable to explain the stability of the atom. And after that, Niels Bohr modified the Rutherford model, and we got the different orbit and the different specific energy level. Then in the second lecture, we have learned the applications of Bohr's model, hydrogen spectrum, Sommerfeld model, drawbacks. Okay, so in the second lecture, we have learned the application of Bohr's model. So with the help of Bohr's model, we can measure the radius, we can measure the velocity of the electron, we can measure the energy level. And by the energy level of the, like say, hydrogen atom, the initial energy level and with the final energy level, we can get the difference of these 2 energy level. Like say, if the electron moves from the lower energy level to the higher energy level, it will absorb the energy. if it like moves from the higher energy level, or you can say the outer orbit to the inner orbit, then it will release energy. And from this energy, we can get the spectrum. So it can be calculated by the Bohr's model. Next, we have also learned the Sommerfeld model. So we have learned that how it is determined that the which, as per the quantum number, which energy level the electron will stay. So today we'll learn the quantum number, and we can understand that for each quantum number has what is the purpose of different quantum numbers. And from this chapter, the students will be able to describe the fundamental properties of atoms, molecules, and the atomic structure. And if you like to get books, so you can avail it from the library. So here, first, I will tell about different orbits, different orbital. So you know from your prerequisite knowledge like S orbital, P orbital, D and F orbital. So here S orbital, consider a single hydrogen atom at a particular instant. The position of electron is plotted. The position is plotted again soon afterwards, and it is a different position. There is no way to tell how it moved from the first place to the second. In hydrogen case, the electron can be found anywhere within a spherical space surrounding the nucleus. Okay, so you can understand that S is the spherical shaped. Next, the p orbital. Not all electrons inhabit S orbital. In fact, very low electron live occupy S orbital. At the first energy level, the only orbital available to electron is the 1s orbital. But at the second level, as well as a 2s orbital, there are 2p orbital. A p orbital is shaped like two identical balloons tied together at the nucleus. At any one energy level, it is possible to have three absolutely equivalent p orbital pointing mutually at right angles to each other. These are arbitrarily given the symbols px, py, pz. This is simply for convenience. The x, y, and z direction change constantly as the atom tumbles in space. Okay, so x-axis. So here you can see that it is x-axis. X-axis. This one is the y-axis. Okay, and this is the z-axis. So px for x-axis, py for y-axis, and pz for the z-axis. Now d and f orbital. So in addition to s and p orbitals, there are two other sets of orbital that becomes available for electron to inhabit at higher energy level. At the third level, there is a set of 5d orbitals with complicated shapes and names, as well as the 3s and 3p orbitals. 3px, 3py, and 3pz. At the third level, there are 9 total orbitals. At the fourth level, as well, 4s, 4p, 40 orbitals, 4s, 4p, 40 orbitals. There are an additional 7 f orbitals, adding up to 16 orbitals in all. So s, p, d, and f orbitals are then available at all higher energy levels as well. Okay, so now I will show the video that what are the shapes of the orbitals and how it remains. Okay, so this is the 1s, that is the spherical shape. This is the 2s, the bigger size, but it is also spherical shaped. Here you are getting like two balloons, that is the 2px, or it is going to the x-axis, and when it is going to the y-axis, that is denoted as 2py, and next it is going to the z-axis, that is denoted as 2pz. Now at the third orbital, first we are getting 3s, then 3px, then we get the 3py as per the y-axis it will come, then we get 3pz, it will remain on z-axis. Then at the fourth orbit we are getting first 4s, that is the spherical, bigger size but spherical. Then we are getting the 3dz squared. Next we are getting 3d x square minus y square, and you can see that how it looks like. So there are 4 balloons and this is 3d xy, and it is 3d xz. So as it is going to the x-axis and the z-axis, it is 3d yz, it is emerging through the z-axis and the y-axis. So in this way, we get the different orbits. Okay, so you can see the atoms from different angles. So it is the 3-dimensional structure, and the names are like x-axis, y-axis, and the z-axis we denote it, we represent. So you have learned, you have seen that the different orbitals, s orbital, p orbital, d and f orbital, and how it looks like. Now you will learn the 4 electronic quantum numbers. So quantum numbers designate specific cells, subcells, orbitals, and spins of electron. Like when we notify our position, like write our position, first we write our country, then state, then district, then city, then our home. So in this way, we there is also first the cell, then subcell, orbital, and spin of electron. So this means that they describe completely the characteristics of an electron in an atom. So what it describes? It describes completely the characteristics of an electron in an atom. It is to describe each unique solution to the Schrodinger equation or the wave function of electrons in an atom. There are a total of 4 quantum numbers. Number 1, the principal quantum number, the orbital angular momentum quantum number L, the magnetic quantum number that is represented by M, and the electron spin quantum number that is represented by Ms. The principal quantum number N describes, so you have to learn what is the significance of each quantum number. So the principal quantum number N describes the energy of an electron and the most probable distance of the electron from nucleus. In other words, it refers to the size of the orbital and the energy level an electron is placed in. The number of subcells describes the shape of the orbital. It can also be used to determine the number of angular nodes. The magnetic quantum numbers, ML, describes the energy levels in the subcell, and MS refers the spin of electron, which can either be up or down. Okay, so you learned the significance of 4 quantum number. So the principal quantum number N, the principal quantum number designates the principal electron cell because N describes the most probable distance of the electron from the nucleus. The larger the number N is, the farther the electron is from the nucleus. The larger the size of the orbital, the larger the atom is. N can be positive integer starting from 1. 1 designate the first principal cell, the innermost cell. The first principal cell is also called the ground state or lower energy state. Okay, so you can understand that we got the different cell. So first cell N is equal to 1, second is N is equal to 2, third one is N is equal to 3 in this way. So when it moves far from that means if N is equal to 3, so radius increases, so it is far from the nucleus. And also its size becomes larger. The orbital angular momentum quantum number L. The orbital angular momentum quantum number determines the shape of an orbital and therefore the angular distribution. The number of angular nodes is equal to the value of the angular momentum quantum number L. Each value of L indicates a specific SPDF subcell. So each unique in shape. The value of L is dependent on the principal quantum number N. So unlike N, the value of L can be 0. It can also be positive integer, but it cannot be larger than 1 less than the principal number N minus 1. Okay, so N maybe it can be started from 0, 1, 2, 3, 4. So the last will be N minus 1. It cannot be larger than the N. The magnetic quantum number ML determines the number of orbitals and their orientation within a subcell. Consequently, its value depends on the orbital angular momentum quantum number L. Given a certain L, ML, an interval ranging from minus L to plus L. negative integer or positive integer. The electron spin quantum number m is, unlike NL and ML, the electron spin quantum number ms does not depend on another quantum number. So you have seen the previous numbers depends on the another quantum number, but here it does not depend. It designates the direction of the electron spin and may have a spin of plus half 1/2 represented by, you can see the upward arrow, or minus half represented by downward arrow. Okay, this way. This means that when ms is positive, the electron has an upward spin, which can be referred to as spin up. When it is negative, electron has a downward spin, so it is spin down. The significance of the electron spin quantum number is its determination of an atom's ability to generate a magnetic field or not. So example, list the possible combinations of all quantum numbers when n is equal to 2, l is equal to 1 and m is equal to 0. So what will be the solution? The fourth quantum number is independent, as you know. So, independent of first three, allowing the first three quantum number of 2 electrons to be the same. So, the spin can be either plus half or minus half. There are two combinations. Okay, here you can see the two combination, n is equal to 2, l is equal to 1, ml is equal to 0. So, ms will be equal to plus half and n is equal to 2, l is equal to 1, ml is equal to 0, ms may be minus half. So, spin either may be plus half or minus half, either spin up or spin down. So, for the subcells, the number of values of the orbital angular number L can also be used to identify the numbers of subcells in a principal electron cell. So, when n is equal to 1, n is equal to 1, L is equal to 0. L takes on one value and thus there can only be one subcell. When n is equal to 2, L is equal to 0 and 1. L takes on two values, thus there are two possible subcells. When n is equal to 3, L may be 0, 1 and 2. So, L takes on three values and thus there are three possible subcells. Okay. After looking at the example above, we see that the value of n is equal to the number of subcell as the principal electronic cell. So, n is equal to 1 has one subcell, n is equal to 2 has two subcells, n is equal to 3 has three subcells. And you have seen that for one, when it is 1, there is only one s. When it is 2, then 2s and 2p, px, py, pz. In this way, it increases. We get the subsets. Therefore, principal cell with n is equal to 1 has 1s subcell, that is L is equal to 0. Principal cell with n is equal to 2 has 1 S subcell and 1 P subcell. Principal cell with n is equal to 3 So you get, first you get n is equal to 1, then n is equal to 2. Now n is equal to 3 has 1 s subcell, 1 p subcell, 1 d subcell. So L is equal to 0, 1, 2. We can designate a principal quantum number n and a certain subcell by combining the value of n and the name of the subcell, which can be found using L. For example, 3p refers to the third principal quantum number, n is equal to 3, and p subcell L is equal to 1. So in this way, we can get all the quantum numbers. And atomic orbitals, the atomic orbitals is defined as the three-dimensional space in the atom where the probability of finding electron is maximum. The orbitals are of 4 types. I have shown in first, that is the SPDF. The number of orbitals in a subcell is equivalent to the number of values of magnetic quantum number ML taken. A helpful equation to determine the number of orbitals is 2L plus 1. Okay, so if we like say L is 0, then we can write that 2 into 0 plus 1 in this way. This equation will not give you the value of ML, but the number of possible values that ML can take in a particular orbital. For example, if L is equal to 1, then what will be ML? You can calculate. Okay. ML can have values like -1, 0, and or +1. The values of 2L plus 1 will be 3. And there will be 3 different orbitals. The names of the orbitals or the subcells you got, that is SPD. Okay, so if L is equal to 0, if L is equal to 0, then you are getting that s orbital. Here for 1, you got the p orbital, and for next one, second one, p orbital and the d orbital. M1, that will be 0, p for p orbital, -1, 0, +1. For d orbital, -2, -1, 0, +1, +2. So number of orbitals in designated subcell 1, 3, 5. So in this way, you can get all the quantum numbers. So if I summarize what you have learned today, you have learned the quantum numbers, 4 types of quantum numbers. What are they? Can anybody tell? First is the principal quantum numbers n. We understand that how far it is from the nucleus. The orbit is how far from the nucleus. Next is the, so first we got the principal quantum number. Second is the orbital angular momentum quantum number. Third one is the magnetic quantum number and the electron spin quantum number. So first 3, there is the relationship, correlationship, but the spin quantum number, you know, there is only 2 spin, either +½ or -½ So in this way, we can get the idea of the different quantum number, and we can tell the position of the electron in an atom. And we have also learned the atomic orbital, that is SPDF. D and F, and we have also seen the different structure of the SPDF in this way and how it remains in space. Also, we have seen this. So I hope you can answer all the questions. Like say if I give for like say calculate the different types of quantum numbers. Okay, this type of questions. So today I like to give you a quiz. Okay, so on this you have to join with this game. If you join the game, then you will enjoy very much. So here, when there will be any player, then only I can start the game. So here I am the only player. Here I am now starting the game to show you how it works. It is a very interesting game. All of you like to play different games. If it is correct, so you will see the score. Again, I am doing the correct. Okay, I am playing the correctly. And my score is increasing. Okay, it is also correct. When there will be more players, then you will get the competition, you will enjoy. You will see your score. Oops, it is wrong answer. To show you that how it comes. Okay, again correct. If you play the game, you will enjoy very much. And those who are who will get more score, they will go upward direction above. Those who will get lesser, they will come downward direction. So continuously you will see this part. So there are 10 questions I have given. So I am sending the link. Then you can play it when you join with the link. Okay, so there is no player other than me. Okay, this is my score. So I am only the winner as there is nobody for in this competition. Okay, so in this way you can play this game and you will enjoy very much. So I hope you have enjoyed today's session. So now I am ending the session for today and thank you everyone.